Assalamualaikum and a very good day. So today we are going to proceed on chapter 6, hypothesis testing. Okay, but for two sample tests. Okay, so that's mean our previous video is on the single mean. That's mean we have only one distribution. But in this video we are going to learn how to do the testing on the hypothesis, for the two sample means. Okay, that means we have two distribution. Okay, now so there are 6 cases. We have case A, B, C, D, E, and F. Okay, so the variance known or unknown. Okay, so for case A and B is for the variance known, and for the case C, D, E, and F for the variance unknown. Okay, so for the difference between the case A and case B, okay, the variance is known. Okay, so the difference is that the sample size, okay, for the N1, that means the sample size for the first distribution, and 2 is the sample size for the second distribution, is greater or equal to 30. And for case B, the N1 and N2 is less than 30. So if we get the questions, okay, in which the samples is greater than 30 and the variance is not, that means we have to use this formula. But if we get the question in which the variance is not, but the sample size is less than 30, that means we have to use this formula. So this Z test. Okay, we are going to use the Z test for the statistical test for the case A and case B. Okay, so if we look at this, okay, there is no difference in the formula between the case A and case B. Okay, so for the case C, D, E, and F is that the variance is unknown. Okay, but for case C, okay, the variance is unknown, but the N1 and N2 is greater and equal to 30. So that means if we get the question, the variance is unknown, but the sample size is greater or equal to 30, that means we are going to use this formula. Okay, Z test, also the Z test, but this formula. Okay, so there will be the difference. Okay, for this case A and case B, our sigma, okay, our standard deviation, sorry, this one variance. The variance is for the population because we know the variance of the population. But for the C, we use the standard deviation, sorry, the variance of the sample because the variance is unknown. Okay, for case D, E, and F, okay, all the number of sample is less than 30. Okay, so the difference is that for the case D, the variance is unknown and equal. Okay, so the difference between D, E, and F is that the variances of the population is unknown and equal. So, and your N1, N2 is less than 30, then we are going to use the T test. Okay, so this is the formula of the T test. Okay, for the when your variance is unknown, okay, and your N is less than 30, okay, so the variance is unknown and not equal, so we have the case E and F. Okay, so when N1 is equal N2 and is less than 30, okay, for case A, for the N which has the same value, that means your N1 is equal to N2, then you have to use the case E. Is make sure that your N is less than 30. So for case F, okay, your variance of the population is unknown and not equal. Okay, So your N1, N2 is less than 30. So you are going to use the t-test. Okay, now we look at the examples. Okay, in mathematics quiz, the sample size of 2 parts are 10 students. That means we have two distributions. We have N1 and also we have an N2, which equal to 10, in which the number of sample is equal. Okay, equal to 10. Okay, so for part 1, the mean score. Okay, so that means your mean score for X1. Okay, was 35 with standard deviation of 2.5. So your standard deviation is 2.5. Okay, this one is for the first distribution. That's why I denoted as X1 and also S1. While in part 2, the mean score was 24. Okay, the mean is 24. With standard deviation is equal to 2.1. Okay, so this one is the samples, right? So we didn't know about the population of the variance. So it's only given the standard deviation of the sample. Test the difference between the performance of the two parts by using 0.01 of significant level. That means we want to test the difference. That means your H1, okay, your mu1 is not equal to mu2. You want to test the difference. And your significant levels, that means your alpha is equal to 0.01. Okay, then we must assume that the variances of the populations C are unknown but not equal. Okay, for this topic, okay, for the two mean samples, okay, usually the question we give the type of your question. For example, for this question, we assume the variances of populations are unknown but not equal. Okay, now, if the variance are unknown, okay, and not equal, so it can be from the case E or case F, okay, but for case E, okay, the N1 is equal to N2, and for the case F, the N1 and 2 is not same, okay, but both is less than 30. So by looking for of these properties, we know that this is from case E. Okay, that means we are going to use the case E to solve this problem. Okay, since we know that we are going to use case E, okay, this one is your case E. Okay, so our N1 is equal to N2 is equal to 10. Okay, that's mean which is less than 30. Then it's also given that your variance of the population is unknown and not equal. Okay, so we are going to use the t-test. Okay, so the formula, okay, we already have the X1, the sample mean of the part 1, and we also have the sample mean of the part 2. Minus with the, okay, this one is the sample mean of the population. So your U1 minus mu2 is equal to 0. So please keep in your mind for mu1 minus mu2 is equal to 0. It's good same for all the formula in all cases. Okay, that means case C, D, A, B, F, all the mu1 minus mu2, okay, is equal to 0. Okay, now, then we have n, okay, n is equal to 10, okay, so we have the S1 square, okay, this one is the variance. Okay, the question give you of the sample, standard deviation of the sample, which is equal to 2.5, and for sample of part 2 is 2.1, but the question asks for the variance, so that means we have to square. Okay, so this one is a very important part. Our V is equal to n minus 1. Okay, this is degree of freedom. Okay, we are going to use the theta's. Okay, table distribution 7. And our degree of freedom is 2n minus 1. So your n is 10 minus 1. That means your V is equal to 18. Okay. 10 minus 1 is equal to 9. 9 times 2 is equal to 18. Okay, so that means if we want to look for the theta's, we must have the alpha and also the V. So our V is 18. So how about our alpha? So again, your alpha must be different. Okay, it's given your alpha is 0.01. Okay, but okay, the question asks you to find the difference in which your mu1 is not equal to your mu2. So this is the two sample types. Okay, so that means your alpha must be divided by 2. Then you get your alpha is 0.005. Okay, so that means your t-test is 0.05 and your V is equal to 18. Okay, now. Okay, so the first step is our null hypothesis. To determine our null hypothesis, H0 and also our alternative hypothesis. So our alternative hypothesis is from the claim, okay, from the question in which we want to test the difference. So that means we want to test whether the mu1, okay, is not equal to the mu2. Okay, so there is a difference between the mu1 and also the mu2, the mean. Okay, so the H0 is that the mean of the population is equal. Okay, so in the step 2, we have two tail tests. Okay, because we want to test the difference. Okay, when we want to test the difference, that means we have two tail tests. So our alpha must be divided by 2. So we have our alpha 0.01, so divided by 2 we get 0.005. Okay, so we already determined that it is from the case E. So from the case E, we must use the t-test. Okay, so it is given the degree of freedom is equal to 2 times n minus 1. So our n is equal to 10. 10 minus 1 is 9. So our degree of freedom is 18. Okay, so our alpha is 0.005. So by looking at the table 7, okay, T distribution table, when your alpha is 0.05 and your V is equal to 18, then you get 2.878. Okay, please refer to the previous video, okay, on how to look at the t-test table. Okay, now we must reject the H0. Okay, if our t-test fall in the region, our TC less than negative 2.878 or TC greater than positive 2.878. So how to determine this? It's come from your two-tail test. And two-tail test, that means we have to reject if the t-test fall in the critical region which is less than negative and greater than positive. Okay, so the next step is that, okay, we must get our t-test. Okay, because we want to know whether we want to reject or not reject the null hypothesis. So our t-test comes from the case E, okay, in which the formula is the x bar 1 minus x bar 2. So from our question, we already have this information, okay. Our x bar 1 is 35, x bar 2 is 24. And our mu1 minus mu2 is always equal to 0. And 1 over n, our n is equal to 10, in which your n1 and n2 is equal. Then we have a standard deviation. Okay, we are given the standard deviation of the population. But in this formula, we are going to use the variance of the population. That's why we must square Okay, the standard deviation. Then we get is equal to 10.65403. So in the step 4, okay, we determine whether we want to reject or not the null hypothesis. Since your t-test 10.65403 is greater than our 2.478, so we must reject the null hypothesis. Okay, we reject the H naught. So when we reject the H naught, we have the enough evidence to support our H1, in which our claim in H1 there is a significant difference between the performance of two parts. Okay, now we proceed to the next example. Okay, so the data, okay, is about the average of my age recorded by two types of engines. Okay, so the sample size of engine type 1 is 18. Okay, with the sample mean of 114. Okay, so that means we have N1 is equal to 18 and our sample mean is equal to 114. While the sample size of type 2 is 14. So your N2 is 14. Your sample mean is 1, 2, 3. If sample standard deviation of both are, okay, sample standard deviation, that means your S1 standard deviation of the sample 1.6 and also standard deviation of sample for 2, okay, is 1.7. Okay, we have 1.6 and 1.7. Test the hypothesis use of 0.02511 of significance. That means your alpha is 0.025. Okay, the average of my age engine type 1 is lower than type 2. Okay, so your mu1 is lower than your mu2. Your mu1 is less than your mu2. Okay, so this is our claim. Okay, assume the variances populations are known but equal. So if the variances population is unknown, it's come from the case D. Okay, unknown and equal is from the case D. Okay, this one is case D. Okay, now we look at the formula of case D. Okay, now we look on the case D. Okay, so from the question is given that the variance population is unknown. Okay, so it's unknown and equal. Okay, unknown but equal. Okay, so our N1 is equal to 18 and our N2 is equal to 14. That means which is less than 30. Okay, so we have also the X bar 1 and also X bar 2. That means the sample mean of the type 1 and also the type 2. And we know that our mu1 minus mu2 is equal to 0. Okay, then we know that our N1 is equal to 18 and 2 is equal to 14. And we have 1 over N1 and 1 over N2. Okay, so this is the t-test. That means we must have the degree of freedom. So for case D, it is given that our degree of freedom is N1 plus N2 minus 2. That means our N1 is 18, N2 is 14 minus 2. Okay, so our alpha is 0.025. Okay, but the question given, okay, our H1. Okay, our H1 is mean of the population 1 is lower than the mu2. Okay, so that means that it is a left tail test. So that means your alpha is 0.025. No need to divide by 2. Okay, so we have here SP. So this SP is not given from the question. Okay, so in your final, okay, usually we have the formula of the SP. Okay, now we look the formula in your finals. Okay, this is the complete formula, okay, for case D for the variance unknown and equal, okay, in which your N1 and N2 less than 30. So we have the t-test, we have the degree freedom, in which your SP, okay, so that means we must calculate our SP first, is equal to the square root of N1, okay, that means from the example we have 18, and 2 is 14, that means this one is the variance. Okay, we have standard deviation square. Okay, that means this is variance for type 1 and also the variance for type 2 over the n1 plus n2 minus with 2. That means we must calculate the SP, then we substitute the value of SP in our formula. Okay, so we look at these examples. Okay, so to solve the example 14, okay, the step 1 we have the H naught, okay, in which our mean of the proportion is equal to the mean of question type 1 and type 2. Then our null hypothesis is referred to the claim from the question, in which okay, now we look how to solve the example 14. Okay, so for step 1, okay, we have the null hypothesis in which our mu1 is equal to mu2, and our h1, our alternative hypothesis, is referred to the claim from the question in which the type 1 is lower than the type 2. Okay, that's mean your mean of population in mu1 is less than mu2. Okay, so in step 2, okay, we know that is a left tail test, okay, because the mu1 is less than mu2. So it's from the case B, okay. So we are going to use the T distribution in which our alpha is 0.025 and our degree of freedom, okay, from the formula given, n1 plus n2 minus 2, that means 18 plus 40 minus 2 is equal to 30. So by looking table 7, T distribution table, then we get 2.0.2. Okay, now in this case D, we have to calculate the SP, okay, in which the formula of the SP, okay, we got this answer 1.64408, okay, or is equal to 1.6441, okay, so we can approximate to 1.6441. Okay, so we reject the H naught if the t-test fall in the region of critical value less than negative 2.042 because this is a left tail test. Okay, now in the step 3, okay, we substitute all the information given from the questions and the SP that we already calculate from the step 2. Then we get our t-test is negative 15.3619. So the test value is less than the negative 2.042. That means we have to reject the H naught. And if we reject the H naught, we have the enough evidence to support our H1, in which the H1 claimed that the average gas mileage for engine type 1 is significantly less than the average gas mileage for engine type 2. Okay, this is how we solve our problem in case D. Okay, now, so this is the formula, okay, that will be given in your final examination. So for chapter 6, okay, hypothesis testing, you are only given this formula. Okay, so when your variances are known, equal, and also unknown not equal. Okay, so we have the n1 and 2 less than 30, or n1 is equal to n2, or n1, n2 is less than 30. Okay, so the difference between these three formula, the first difference you must determine, okay, whether the variance is equal or not equal. So if equal, then you have to use this formula, the t-test. But if the variance is not equal, so you have two choices. Okay, then you must look whether your n1 is same or not. Okay, so both is less than 30. So you are going to use the t-test. Okay, now if you look at this formula, all is from the t-test. We have to use the statistical test is from the t-test. Okay, now the most important thing on the t-test is that the degree of freedom, the v. If we see from this first unknown and equals, okay, the v is n1 plus n2 minus 2. But for this one, your v is 2 times n minus 1. And for this one, your degree of freedom v is this formula. Okay, if we look at this formula, s1 square, s2 square, that means this is the variance of the sample. This one is the variance of the sample. N1 is the sample size, and 2 is the sample size. Okay, for both two distributions, distribution 1 and distribution 2. Then you have to square. Over, again, we have the variance of the sample for distribution 1, variance of the sample for distribution 2 over the number of sample 1 and number of sample 2. Then N1 is sample size 1 and also the sample size 2. So you have to solve this degree of freedom for V. Okay, so then we must know that when we want to use the distribution, the T distribution, we must have the degree of freedom. So we have the V different calculation of the V. The second one is the alpha. So how to determine the alpha? The alpha is the significant level that will be given from the question. So to determine or to identify the value of alpha, you must look at the claim of the question. If the question claim that the type 1 is lower than the type 2, that means your mu1 is less than mu2. Or the type 1 is greater than the type 2, that means we have the mu1 greater than mu2. Okay, so if less than, that means you have to use the left tail test. If greater than, that means you have to use the right tail test. Okay, so for the one tail test, okay, you must use the alpha. The value must be alpha. Okay, the original given from the question. But if the question asks you test the difference, okay, of the test, okay, we have the claim that the mu1 is not equal to mu2. That means this is the two-tailed test. Okay, the meaning of the two-tailed test, that means you have the right tail test and also the left tail test. That means you must divide your alpha by 2. Okay, so this is how you determine your alpha. Okay, your alpha you can get original, okay, from the questions. Okay, if it's one tail test, that means right tail test of left tail test. But you must divide by 2 if it's a two tail test. Okay, so then you must know in which cases. Okay, so usually for your final examination, the question will state that, okay, what type of the question, the variance. Okay, variance of the portion is unknown but equal, or maybe it's given the variance of the portion is unknown but not equal. So you must determine on your own, okay, by looking at the type of the variance and also the sample size. Okay, then you just use the formula. Okay, if the t-test, then you must refer to the table 7. Okay, T distribution table. And if the question asks you to use the z-test, then you must refer to the normal distribution table, table 3. Okay, I think that's all about the chapter 6 on the hypothesis testing.